In today's session, we'll see the process synchronization using other problems or using other concepts. So we have seen whenever the processes share the same resources or share the same memory, so this flow must be properly and consistent. Now for example, take the printer. Printer is shared among multiple students. So every student should be able to get the printer. So there is a common one printer and shared among multiple students. So these students are like processes and which are going to share the same resource, that is printer. So the flow and the consistency must be proper here so that the printer in between should not get stuck, and every processes must be able to take the printout and use the common resource. So this synchronization should happen properly between multiple processes because they are sharing the same resource. So that we are going to see how to solve this, and based on that algorithms are there and all. So we'll see one by one by taking the topics. So cooperating processes. So process synchronization in a cooperating process is very important. So concurrent access to shared data may result in data inconsistency. So if multiple processes are sharing the same resource like memory or any other resource, then there inconsistency arises. Maintaining data consistency requires mechanisms to ensure the orderly execution of cooperating processes. So for proper synchronization, there are some mechanisms used for orderly execution of cooperating processes. So they can share the same resources without any interruptions. So we'll study one concept, that is producer-consumer problem. So this producer and consumer are two processes, and how to synchronize between these two processes, that we are going to see. So producer is a simple process. Producer is going to produce something which puts data in a memory, and that memory is buffer. So here we have limited size of buffer. Producer cannot put any data if that buffer is full, and consumer will consume something. So consumer will take data out from that memory and will create a space. If the buffer is empty, consumer cannot consume anything. So there must be synchronization between these two processes. When producer produces, then only the consumer can consume. Producer before producing needs to check whether there is a space or no, whether there is empty slot or no. If there is empty slot, then only the producer can add data into that. And even the consumer before consuming, before taking out the data, should check whether there is a slot with data or no. So at least one slot must be with data, then only the consumer can consume it. So at the same time, if both producer and consumer must not try to perform the same operation. At same time, the producer should not try to produce the data and consumer should not try to consume the data. Otherwise, the clashes arises and the problem arises there. So the problem arises when producer and consumer are not working in synchronization. So here producer should try to insert data into empty slot of the buffer, and consumer should try to remove the data from filled slot in buffer. That is producer consumer problem. It is also called as bounded buffer problem. Is an example of multi-process synchronization problem, and it has two processes, producer and consumer, which are going to share a common sized buffer used as a queue. And producer's task is to generate data and put it into the buffer, and consumer is consuming the data one piece at a time. So there is going to be one buffer, and this we called as memory buffer, and this memory buffer has some fixed size. Suppose we have here 5 slots, 2, 3 and 5 slots. So what is the work of producer? Producer work is to add the data into the slots. So producer, before adding the data into the slots, have to check whether there are empty cells or no. If there are empty cells, then only the producer can add the data. It can add any data to the slots if they are empty. Now it has added 3 slots, the data in the 3 slots. Now what is the work of the consumer? The work of the consumer is to consume the data which is added by the producer. So the consumer is going to consume this data. That means it is going to take out this data out of memory. So when it consumes the data out of the memory means these slots are going to be empty. These slots are going to be empty. So the consumer before consuming the data have to take care that there is a data inside the slots. There is data inside the slots. Okay. See, now it has consumed all the data. Now consumer has consumed all the data. Now all slots are empty. Now if the consumer tries to consume the data from the empty slots, it gets stuck there. The problem arises. And even the producer, when the buffer is full, now it cannot add the data here. Even the producer cannot add the data. So if the producer goes to add the data in a full slots, then even the producer will get the problem. The problem arises and even the producer will get stuck and the consumer will get stuck there. So as consumer has consumed these first 3 slots, these were empty. Then the producer has added once more to the slots and it has become now full. So when the slots are full, the producer cannot add any data into the buffer full. So the clashes arises here. So both producer and consumer should take care of that. So the problem is to make sure that the producer should not add data into the buffer if it's full. And the consumer should won't try to remove data from an empty buffer. So this is the algorithm for this bounded buffer problem. Now let us see whether this algorithm is accurate or no and whether it synchronizes between the processes or not. They are given here the fixed buffer size 10. Variables have been declared here. Buffer size variable declared, and in and out, these are the indexes maintained for producer and consumer. These are the indexes. Out is for consumer. So this is the algorithm for producer. Now when the producer wants to add the data to the slot, it is going to enter into the loop, and first it is going to check for the while loop here. Now this counter variable is very important here. See, here also counter variable is important because this counter variable is shared by both producer and consumer. So this counter variable will tell that how many elements are currently available in the buffer. So when producer produces an element, this counter variable is increased, and when consumer consumes an element, this counter variable is decreased. So it will keep track, this counter variable will keep track how many elements are added and how many elements are consumed. So first producer is going to check out the counter value with the buffer size. Now see, there is a buffer. Now the buffer size is already the data has been added here in the buffer. Now even the counter value will be here 4. The counter value will be here 4. So counter value here is 4. So when the counter variable is equal to buffer size, now when counter variable is equal to buffer size, then all slots are full here and the producer cannot add any data into the slot. So it will get stuck here in the loop, means it is going to wait here in the loop. So if this condition is true, then the producer is going to wait in the loop, and when the condition is false, it is going to add the elements, it is going to add the data to the free slots. It is going to add the data to the free slots. If the condition is false, we need to understand that there are free slots in the buffer, and it will add the data into the buffer in using the index. And after adding the data, it is going to increment the value of index, and then it will increment the value of counter. This is the algorithm for consumer. So when the consumer wants to consume, it is going to enter into the loop, and now it is going to check the value of counter with a 0. So when the value of counter is equal to 0, so we should understand that all slots are empty here. So when the counter value is 0, that means all slots are empty. None of the data is added here. So this condition is true. So if this condition is true, the consumer cannot consume from the empty slots. So the consumer will wait here, means it will get stuck here until the condition becomes false. When the condition becomes false, it is going to add the data to the, it is going to consume the data from the slots. So it is going to consume the data from the slots and out index will keep track of that, and it will increment the value of index because it has consumed it, and after consuming it is going to decrease the value of counter. So from this counter variable you will understand how many elements have been added and how many elements have been consumed. So the problem arises in this algorithm is due to counter variable, because this counter variable is shared by both producer and consumer. Because see, when the producer adds the item to the data to the buffer, then updates the counter value. But before updating the counter value, if the consumer access the counter value, then the consumer may access wrong value. So here both producer and consumer are in a race to access, to grab that counter variable. So this we call it as race condition, because both variables are in a race to grab the counter variable, like who can use the first variable and who can access the first. So both are in a race to access the value of counter because they are sharing the same variable counter. So due to this the clashes arises and the producer consumer may access the wrong values, and because of that they may not synchronize and the clashes arises. So this type of problem we call it as race condition. So race condition is when both processes are sharing the same variable and they are trying to grab the same variable. So there is a race between two processes that who can grab that variable first. So that is a race condition, and because of this race condition there is no proper synchronization between the processes and the problem arises, clashes arises. So the situation where several processes access and manipulate shared data concurrently, the final value of the shared data depends upon which process finishes last. So whichever process has grabbed the variable first, so the further process will depend on that latest value. So to prevent race conditions, concurrent processes must be synchronized properly. So prevent this race condition, it must be synchronized properly. So there are some techniques which can be used to synchronize this all properly. Let us see the example on race condition. So there are two processes, process A and process B. First, process A has to execute this coding and then only the process B has to execute. So after reading the value of X by process A, then only the process B can read the value of X. So first process A reads the value of X, that is 10. Then process A is going to increment the value of X. But before incrementing, in between the B interrupts and reads the value of X, that is 10. Now here A has read the value of X. It is going to increment the value of X, that is 20. Now here B, instead of reading the value 20, B has interrupted and has read the value of X, that is 10. So here after incrementing the value of X, the B X value is going to be 20. So here the result is wrong. So this is not properly synchronized because in between the process B has interrupted and it has read the wrong value, and it has, before updating the value by process A, it has already read a wrong value and it is showing the wrong result. So such type of problems arises when same variable is shared by more than one processes. So to avoid this problem, locking system can be used here. So this locking system is like a critical section. So this coding can be locked when process A is executing this part. When process A is reading the value of x, it reads the value of x, that is 10. Now in between, if the process B interrupts, it tries to read the value of x, but it is already locked. So it cannot read the value of x because it is now locked. So when one process is accessing the variable, and if other process try to access the same variable, then it cannot access because it is locked. So here process A increments the value of x and it is going to be 20. Now after execution of process A has executed this part. Now the process B will be given the charge to execute the same code to access the same variable. So process B is going to read the value of x, that is 20. Now after incrementing the value of x, it is going to be 30. So now it is giving the correct result. In earlier, the process B has interrupted and read the value 10. Now here, as the coding was locked, it was not allowing the other process to interrupt. It has read the correct value 20 and it has given the result 30. So this is how we can solve the synchronization problem using various mechanisms. So locking is one mechanism from that which can solve this synchronization problem, and there are also many algorithms. We are going to see that in the next topic, next session. Thank you.